The goal for today's lesson was to be able to look at how equations help us describe relationships and constraints. And telling which quantities in a situation can vary, which ones cannot, using letters and numbers to write equations representing the relationships in a situation. This is arguably one of like the harder things to do in algebra, is to write the equations, set them up. But hopefully, you know, these first few lessons, because we're still doing this kind of something similar tomorrow. It's like the part 2 of today's lesson is modeling relationships. So as you work through your practices, really you should be working through the one from yesterday, because not everyone met that goal for 80% or higher. And the one from today, also 80% or higher. I imagine that that'll take you the majority of the time in math lab to do, but if you finish early, so maybe I'll add a few things to this list. Things that you could consider doing are correcting the most recent version of your unit tests, things like that. Once we take like a unit test, for example, I don't let you go back and retake those quizzes. All right, the syllabus lets you retake those quizzes up until the unit test. But if you notice, I matched those lower quiz scores to whatever you got on the unit test. So when you do correct it or whatever, retake it if you absolutely needed to, and that's the requirements to, I do still go back and match those scores. So that I'll add that to the list, but I really push you to retake your unit tests more than your quizzes. Any questions? All right, so shoot for the 80% or higher on these two things first. That'll be like your points for the day. And then I'll add possible test correction. So that way, if you were planning on coming after school, you maybe won't have to anymore. You can just get it done for class. All right, so get to it. Let me know if you have questions as we go. For the end, I'll pull up like the most missed one if no one has any questions other else. All right, so we have Elena bikes 20 minutes each day for exercise, and we're writing an equation to describe the relationship between her distance in miles D and her biking speed in miles per hour when she bikes. So the variables that it defines specifically are D, which is distance in miles. And then her biking speed, they didn't give us a variable, but, and yeah, they sent down here, they have some variables, but we're not really sure which is which, so we'll see. But at a constant speed of 13 miles per hour for the entire 20 minutes. So if it's 13 miles per hour for the entire 20 minutes, look at all the ones that have maybe a 13 in them as a good starting place. And okay, so if the 13 is a constant speed for the entire 20 minutes, that relates to her distance in miles now.
I got 13 times 1.
So here, D is distance in miles, and it's telling me she goes 13 miles per hour, but she's only biking for 20 minutes. So how much of an hour is 20 minutes?
An hour is 60 minutes, so we have to multiply 13 times 2 to get how much she gets down.
Except for that, she's only going 20 minutes. So she is going 13 miles an hour, but if she's only going for 20 minutes, how many miles is she actually going? A third of that. So I'm thinking that it's this one. Anyone disagree with me on that?
It's not the
What? It's not the 1/2 one? Okay, well, that would be why, because 1/2 would probably be for 30 minutes of an hour, not 20 minutes. that makes it more sense? Okay, because that would actually give me the distance she went, which would be what D equals, so that makes sense. For B, we have a constant speed of 15 miles per hour for the first 5 minutes. So for the first 5 minutes, how much of an hour, since they're giving it to us in miles per hour, how much of an hour is 5 minutes? 112, right? Because 5 out of 60, yeah, simplify that, it is 112. And to get the distance in miles, what would you multiply the 112 by? Because remember, the whole thing we're trying to figure out is her distance in miles.
5 miles per hour, she's like
So it would be
15.
112 times 15, so it's looking like it's this one. So let's keep reading. And then at 12 miles per hour for the last 15 minutes, how much of an hour is 15 minutes? A fourth. So I would say that this one is this one. So hopefully that's why. So that would literally be the math that we're doing to solve it. If you were like, no, and actually I would divide it by 4, timesing by 1/4 is the same as dividing by 4. All right, but anyway, now down here, at a constant speed of m miles per hour, for the first 5 minutes, which we said 5 minutes is what of an hour? So between these, it's looking like this one. So let's keep reading. And then at n miles per hour for the last 15 minutes. So 15 minutes is a fourth of an hour. We would times that by n, so it's looking like this one. That matches.
It's the same question, just very.
Exactly. All right, so questions on that? I'm just gonna peek at the answer key and make sure it's labeled right. Occasionally, there are some mistakes, so let me just check. Okay, so questions. Okay, yeah, and it's what we said. All right, so other questions from this practice? Faith? The student on something, on the track team, okay. So we have a student on the track team runs 45 minutes each day as part of her training. She begins her workout by running at a constant rate of 8 miles per hour for A minutes, then slows to a rate of 7.5 miles per hour for B minutes. And we're picking which equation describes the relationship between the distance she runs in miles D and her running speed in miles per hour. So lots to unpack here. My tip would be start with any totals. So does it tell me like, or maybe tell me with a variable or a number, what my total would be? Would be the 45. Okay, so we're wanting to describe the relationship between the distance she runs and her running speed in miles per hour. So it might not be the 45 as my total this time, although that could be a total for like something else that we'll see later down the line. So it's not wanting to know how many minutes she spends doing each thing. It wants to know how many miles she runs. So that is a total, but that won't be the one we're looking for in this one. We're wanting to know the total distance she runs. So for what makes that up would be the other things that are in this. So we have 8 miles per hour for 8 minutes. How would I show that? Would I do like 8 plus A, 8 minus A, 8 times A, 8 divided by A? 8A, I agree. Because if it's 8 miles per hour for 8 minutes, but also remember in that last one we just looked at, if it's 8 miles per hour and then it's saying 8 minutes, what do we have to do with that? With a minute?
Right.
Divide it by 60. So this one looks like it could be it, but it's missing that part. Because if you remember the last example we just did, you can't like use units for hours and then compare that to minutes, like it wouldn't be exactly the same. It's not 8, or, well, it is 8 miles per hour, but A is not hours. Does that make sense? So to convert the minutes to hours, you would divide by 60. So this first one is looking good. And then 7.5 miles per hour for the minutes. I think it would be this one. Questions on that? Okay. Let's see, let's show answers. And we did get it right. It shuffles it, so make sure you pick the right one. Questions on this one? Questions on others? Keegan? This one, okay, let's see. Jada plans to serve milk and healthy cookies for a book club meeting. She is preparing 12 ounces of milk, 4 cookies per person. Including herself, there are 15 people in the club. A package of cookies contains 24 cookies and costs $4.50. Lots to read, sorry. A 1 gallon jug of milk contains 128 ounces, costs $3. Let N be the number of people in the club, M be the ounces of milk, and C represent the number of cookies. B represent Jada's budget in dollars. We're selecting all the equations that could represent the quantities and constraints in this situation. So remember, constraints are what? Things that are limited. And then I think quantities would just be like the things that we could actually like figure out. So the M, like I'll just go like down the list, is for ounces of milk. If we're trying to figure out the number of ounces of milk, we know that 1 gallon contains 128 ounces. Does this kind of like do anything for me, the 12 times 15? Yeah, I don't think so either, because that just has nothing to do with the ounces, which are 128. So I would not pick this one. For the 3M plus 4.5C equals B, well, M is ounces of milk, C is number of cookies, and B is her budget. So, and the milk does cost $3. The 4.5 does refer to the cookies, so is this one making sense? Okay, I agree, because if it's contributing to her budget, which is what B is, you want to know how much these cost. However, the M part is kind of weirding me out, because oh no, I guess that's fine. Okay, we're good. All right, moving on. The N, because this one's 4N equals C, so the N is number of people, and this is equal to the number of cookies. Did she say how many cookies she wants each person to have? Where did you see that? But it definitely did say. So does this make sense for the number of cookies we need is 4 times however many people there are? Yeah, like if I was getting cookies for you guys, but there's like 10 of you normally, oh, 9 of you will count me as 10 for the math, and I would have to get 40 cookies. All right, so then that makes sense. Then down here, for the number of cookies that I need, would it make sense to times the 4 per person times 450? Because remember, C is number of cookies. Maybe if I was looking for the cost of the cookies, but I'm not. C is just number of cookies, right? So this one doesn't help me with what I need. Like, can you have 4.5 of a person? So then don't pick that one, because that would be suggesting the number of cookies I need is 4 for 4.5 people. Like, that doesn't make sense. So then down here. B is for budget. We have 2 times 3, so I'm guessing that's 2 gallons of milk. And then for the cookies, which cost $4.50, we're getting 3 packages. So does that sound like it's making sense? Yeah, the way that those are paired. So I would pick those 3. Let's see what the key says. Okay, so it looks like we mispicked this one. And we should have picked that one. Let me see if that's my error in problem solving or an error in the key. So give me 1 second. Okay, so. So yeah, it's an error in our problem solving. The key is correct. So it says we should have picked the first one. Can anyone tell me why? So M is ounces of milk. I don't really know how to tell it. Maybe I'll just have to ask you on that. Because maybe they can tell me, because I don't know.
And the milk is 12 ounces. 12 ounces for.
Okay. Okay, so that makes sense. Thank you. All right, so we should have picked that one, sorry. And then we should have not picked this one. Now let's see why. This contributes to her budget. M is ounces of milk. But in actuality, we're not paying $3 per ounce, are we? Or are we paying for like a jug of milk? We're paying for a jug of milk, so that's why. The cookies part makes sense. But we're not paying for the ounces of milk, we're paying for the container of milk and M specifically ounces of milk. So I knew that one was funky, but I was just like, whatever, I don't see where else it was breaking it down, but it does break it down over here. He wants 12 ounces of milk per person, but we're not charging by the ounce, we're charging by the container. So don't get that one. Okay, questions on that? Questions on others?
The cheap pizza,
Okay, I do know that this will probably be our last one, but let's see if I can answer it quickly. Large cheese pizzas. Okay. So for this one, it costs $5 each and a large 1-topping pizza costs $6 each. We're writing an equation that represents the total cost of the large and the 1 toppings. So since the large costs $5, you would multiply that by which variable is for the large 1 topping pizzas? Or sorry, large cheese pizzas, I should say. Okay. And then the 1 topping pizzas are $6 each, which I'd multiply by the variable that they said. And then what symbol should I put in between them? Because they both contribute to the cost. So it should be something to that effect. If you put something like that and it marked it wrong, tell me. But yeah, maybe I need to put more correct answers that this could be, because you could have put 60 plus 5C. I would not say put C5 plus D6. Don't do that, because that would be a bit more improper. But I'll add another response to that. So it counts 60 plus 5C. All right. Thanks, guys. I'll see you tomorrow.